solving 3531 lead code count covered buildings. This is not a medium problem, it's an easy problem first of all. And let's check the problem and let's then check the solution. So we have provided a coordinate graph, you can say. We have x and y and it is a map of a city, you can see, and every point represents a building. It is given in x and y. Now it is also one of the most important thing is that it is a unique building. Now, and a building is covered if it has at least one building in all four directions: left, right, above and below. I think problem is pretty straight. So for any building, and we need to find how many number of covered buildings are in our city. So for any building to be covered, it should be covered from all four directions. Okay. So let's check this example. Is this point covered from all directions? No, it is not covered. It is only covered from right direction. Okay. We can check with this point. Is it covered? No, it is not covered. It is covered only from the bottom direction. Is this covered? Yes, it is covered. It is covered from the left, right, up, below. Same for this. Same for this. Okay. Now let's check this one. Is it covered? No, it is not covered. It is covered from bottom and right. It is not covered from top and left. Same goes for this. Same goes for this. Same goes for this. Okay. Now we have one more example. This example is similar to our first example. Okay. Now let's check our constraints. Our constraint says that we can have length as 10 raised to 5. 10 raised to 5. Okay. So what is the naive solution that we can think of? The most naive solution that we can think of, or at least what I have thought, is that for every x there can be a left x, there can be a right x. For every y there can be a top left, a top y and bottom y. And if we are able to find it, we can mark this as a covered building. Okay. Now since we have 10 raised to 5, and for an n square solution it will be giving us a TLE. So where is our solution lies? Our solution lies like this. Let's suppose at this point as well we have some x. We have a point here as well. We have a point, and here as well we have a point. Okay. So if what I mean to say, let's say if this one line, if this x can also be replicated here, then how you would have calculated the answer? Then there will be an answer here as well. So what I mean to say is, rather calculating for every x and every y indexes, what we can do, we can find for every x and for every y what is the minimum x and minimum y we have. Okay. Let's talk about this. This is which index? This is which point? This is 1, 3. This is 1, 3. Now let's just focus on the x-axis. This is lying on the 1. Now for this one, what is the y? For this one, what is the y? The y is 3. Okay. Now I'm asking you to save the minimum y and the maximum y for this one. You will be saving in some vectors that will be checking. Okay. Now let's move here. For this 3, how many points we have? We have this one. Can we make a min and max for min and max of y's that are existing on this x axis at 3? Yes, we can have. So what it is it is this point and this point. Okay, now can we have same thing for this 5 which is at x-axis 5? Okay, one more thing, x and y can be in the range of 1 to n inclusive. Okay, so the minimum value of any coordinate can be 1 1 and the maximum can be n n. Okay, so now we have a rough idea how we are going to solve it. Okay. Now what I mean to say is that for every point, if we know that what is the minimum that we can get on the left side and what is the maximum we can get on the right side, we are sorted for the x direction. Now and the same thing we can store for the y direction as well. what is the what is the what is the value that we can have at max and what is the minimum value we can have at max. Now again, if we traverse in the buildings array, that for every point, let's say the point is the point is 1 the point is 1 comma 3. So for 1 comma 3, I'll first take out 1. What is 1 representing? 1 is at x of x, 1 is representing our y axis, min and max y axis. So we can check, is it lying under our min and max value? Is y lying under our min and max values? Yes, it is lying. Okay, so is it lying in our x, minimum of x and minimum of y value? That will be storing in the y vector. If both of this is yes, then we can say okay, we have covered all 4 directions. Let's check the code. It's very simple, and do a dry run for 3-4 cases, you will be able to get this. Okay, so what I have done, a vector x initialized with n plus 1, since we are given that n can be it is from 1 to n, so I have initialized till n plus 1. Size should be n. Now what I am pushing is vector of int max and int min. Okay, here you can also okay, int max and int min. Now here I am trying to save the minimum and here I will be trying to save the maximum. So let's start. For every building, what is the coordinates we are first taking out? Coordinates are x index and y index. Okay, now let's just focus on one vector. If you are able to understand for one vector, similarly you can maybe to understand for y vector. Let's focus on the x part. What does x of x index of 0 tells us? X index of 0 tells us what is x of x index. X is the vector, x index is this point 1, and what is 0 telling? 0 telling that you need to save the minimum here. Okay, and what will be we will be saving? We will be saving the y coordinates. So for this case, x of x index of 0 is minimum of x of x index of 0, 0 representing that we are saving minimum first, comma y index. Similarly, we can also save our max index. Now, okay. Now, if you are able to understand this part, you will be able to understand this part as well. It is just reversal of coordinates. Okay, bear the noise, guys. Sorry. Now y of y index of 0 is minimum of y of y index of 0, comma x of x index. Okay, if we have to understand from our example, okay, so here what is our y coordinate is 3, right? Now we have y coordinate as 3. Now what we should be saving at this coordinate? We should be saving what is our x for this y, which we will be getting from the x index. We can make our min and max. Now, now, after traversing and after saving all in the buildings, what we can say? We can say that we have a major understanding for every x and for every x for every y. What is the min max building that we have in a city? Now, let's traverse in the buildings area again and check what what values are we standing. Okay, now we are standing at, let's say, here. This is 1 comma 3. Now at 1 comma 3 what we have is, okay, at 1 comma 3 what we have. So let's just talk about x first. X first, we are at 1 comma 3. Here a coordinate is 1. So what should we compare it with? We should compare it with what is lying above, what is lying below, correct? And is it under our minimum and maximum? If yes, okay, if yes, then it is fine, we can move to checking the y coordinate part. So similarly what I have done is x of x index of 0 is compared with the y index. Here guys, please try to understand why we are comparing with a y index, because for each x what we were saving y indexes. See, here we were saving y indexes, right? So we should compare this. Similarly we should compare, for when we are checking for y part, we should compare it with our x indexes. If both of the conditions are matching, we can always have an answer. Let's try to submit this. I've already submitted this and it is working fine. Okay, this is working. Thank you guys. See you in the next video. Do like, comment and share.